Pryn hand up, pawb. Fy enw I yw Owain Wright. Rydw i'n gweithio I dîm Hwb yn Llywodraeth Cymru. Diolch am ymuno â ni heddiw. Good afternoon, everyone. My name is Owain Wright. I work for the Hwb team at Welsh Government. Thank you for joining us today. Croeso cynnes I chi gyd I Hwb yn cyflwyno. Ein cyfres o ddigwyddiadau lle ni'n gwahodd arweinwyr mewn addysg ddigidol I siarad ag athrawon yng Nghymru am yr adnoddau a'r cyfleoedd digidol sydd ar gael I chi. A warm welcome to you all to Hwb Presents, our series of events where we invite leaders in digital education to talk directly to teachers in Wales about the digital tools and opportunities that are available to you. We're delighted to welcome Technocamps today to give you an introduction to programming using microbits and to explore how you could apply its use across the areas of learning and experience within Curriculum for Wales. I just want to give you a fair warning that we're recording today's session and making it available on Hwb for others to access at another time. The Q&A facility within Teams is available for you to ask questions, and we'll do our very best to reply. A final reminder, although I'm sure you probably don't need it, that if you're a primary teacher, you can register for 30 free microbits for your school through the BBC's Microbit the Next Gen campaign. I think that's about it from me. So Dan, it's great to have you with us today. It's over to you to find out more.
Thank you very much. Right, well, hello everyone. Welcome to today's session. And we are going to be getting to know our microbits. So hopefully everyone here today has received their microbits if you have ordered them. I know over 550 schools now have got their microbits in hand. If you haven't and you just join in because they're on the way, then fantastic. So today we're going to be going over this. I'm going to go through some basic code with you, just to give you an introduction in how to use it. And so feel free to follow along with that, either by just using the editor, or if you actually have a microbit to hand, then try putting it on there. But yeah, let's get started. We are Technocamps and we are working with Hwb to roll out this new stage of the microbit. Sorry, it's not responding. Good start. There we go. Microbit the Next Gen has begun its rollout across the UK, and we are fortunate at Technocamps that we have partnered with the Microbit Foundation at BBC to be the designated deliverers of the Next Gen across all of Wales. So Hwb have partnered with us to do this first session to roll out the Next Gen, and hopefully it may be one of many coming up in which we can go through coding microbits with you. So if you're new to the microbit and you've never had one before, or you just haven't got the opportunity to use one in your school, you may be asking yourselves, well, what can my microbit do? Why is everyone making such a fuss over these tiny little computers that have been delivered? And the microbit is actually quite a powerful piece of kit, despite its small size. So it is quite small, it can fit in the palm of your hand, but there are an awful lot of things built into it. On the new version 2s of the microbits, there is a touch button hidden within the logo. So that is a touch sensor, as well as a USB connector. You can connect it to other peripherals. It has now got a microphone, 2 buttons, and a 25 LED screen. So it's not quite the biggest resolution. Your pupils aren't going to be programming Fortnite on their microbits, but it is impressive the amount of things that they can program with just a 25 LED screen. In fact, my co-worker Mark earlier was programming Space Invaders, and he's been playing Space Invaders in the office. So there is quite a lot of scope for the things that you're able to do with a microbit. I've also just realized one of the things that is missing from this diagram is there is also a light sensor hidden within that touch logo, which the BBC has forgotten to include on their diagram, but we will be making use of that light sensor later on. And then again, on the back, even more things built into it. We've got a radio antenna, so the microbits can communicate with one another. So you can create networks of microbits over Bluetooth. You can connect it to a battery so that you don't need it continually plugged into your computer. It now has a speaker in it as well. It's not the biggest speaker, but it can play a whole range of different sounds. And if your school is fortunate to have more money to spend on other peripherals for the microbit, then there is an incredible amount of things that you can do using the pins on the bottom. You can connect them to a whole host of other devices using these pins. Or if you do have some simple electronics, you can just use those pins as a circuit and connect some crocodile clips up to them to do a bunch of different experiments. Okay, so that is the microbit. That is what you've received. That is all the technology that you now have in the palm of your hand, that your learners in school will be able to program quite simply using block-based programming. And this block-based programming is provided by MakeCode. MakeCode is a project created by Microsoft aimed at simplifying programming much in the same way that Scratch does so. So it is a block-based programming language, and there's a lot of different versions of MakeCode to make a whole host of different things. But MakeCode Microbit is the one that we will use to program our microbits. So if you'd like now, you can go to this web address, makecode.microbit.org, if you haven't already, and from there you will be able to program your microbits. Okay, so once we get into makecode.microbit, we can create a new project. You can create an account if you don't have one already, but don't worry about that right now. So click make a new project, and then it'll take you in to the editor, and this is what the editor looks like. Fairly similar to Scratch, but also a few differences. Two of the big differences is that you don't have the typical hat blocks like you have in Scratch. Everything is contained within these loops of a sort. So it gives you two loops to start, the on start loop and the forever loop. Inside the on start loop is any piece of information that you want to start when you turn on the microbit. And inside the forever loop will be anything that you want to run indefinitely. So this is where you're going to code your program inside the coding window. Just like Scratch, you have a palette of blocks that you can look through and choose from. Blocks that will accomplish all sorts of different things. And on the left-hand side, you have your simulator. This is like the stage in Scratch where your program will play, and is one of the real strong points of the MakeCode editor, is that almost anything that you can do with a microbit can be run virtually in the simulator. So if you only have 30 microbits for your entire school, and all of year 5 and 6 are working on the same project, let's say, then you don't need every class to have the microbits at one time. You can all work on it simultaneously using the simulator, and when the learners have completed their projects, then they can download them onto the microbits themselves and watch them work physically. But they can test and run their program using the simulator. So if you don't have a microbit to hand, then don't worry, you can still head to MakeCode and you can still follow along with what we're going to be doing today. So one of our goals at Technocamps is to make all of our workshops, or at least have workshops across every area of learning and experience as per the new Welsh curriculum. We strongly believe in the new curriculum and the digital competency framework, and there is no reason that programming and digital literacy shouldn't be used alongside every one of the AOLEs. And so we have strived to make microbit projects across all of the AOLEs, and I'll come to some of the other ones later on. But firstly, we are going to be looking at health and well-being. And the first activity we're going to try and do is make ourselves an emotion badge. If you haven't heard of emotion badges before, an emotion badge is a way for people to show how they're feeling without having to talk about it out loud. So we can program our microbit to have something like a happy face, and then we can change the emotion and change the face. So this is a very nice and thoughtful project that you could do with your learners, especially those who may need extra help showing how they feel, and a bit of encouragement there. It's a very simple project and can be made with very young learners in schools. And that's how we'll begin. So in the MakeCode editor, under the input section, there are a lot of options for inputs. And as I said, every microbit has 2 buttons. Now I'm going to switch back and forth between my screen here. Zoom in so everyone can see nicely. So we get given the 2 initial loops that we're able to make use of. But we're not going to make use of them for this first project. Instead, we're going to go up to our input tab and choose the on button A pressed. I can drag that out and drag it into the editor. Go on, get rid of them because I don't need them. And a lot of different things in microbit have little drop-down menus here, so we can choose which button we want to use, whether we want to use both of them at the same time, however you want your code to run. And on button A pressed, we are going to want to show some emotion. So if we go up to basic, this is where a lot of the basic blocks, the simple things that you commonly use, are stored, and we've got the show icon block, which we can drag in and pop into our on button A pressed loop. And then using the drop-down menu again, we can choose a smiley face. As I said, this can all be run in the simulator. So if your learner is happy, they can show a happy face. Now, what I want you to do is have a play around with this a moment and try using the different input blocks to show different emotions. So for instance, I could bring in an on shake, and on shake, maybe I want to show another icon, and I want my learner to be a bit confused if they're shaking it. Is that a confused face? I don't know. But yeah, maybe a shake is equivalent to confusion. And again, on the simulator, obviously you don't need to shake your entire computer screen. The simulator adapts to this and can work out just by moving across it that that's a shaking motion. If we replay it, if I'm slow, nothing happens, but if I do that, there we go, that equates to a shaking motion. So again, this is the very strong point with MakeCode microbit, is how adaptable it is to being used as a simulator. Obviously, using the microbits themselves are very powerful in and of itself, because having your learners be able to program something like this in not a lot of time. A lot of the programs you make won't necessarily be particularly complicated. They will just encourage logical and computational thinking, and then being able to take this off a screen and physically hold it in their hands to be able to see the work that they've put in actually come to fruition on a real device is a very powerful tool indeed. So the microbits are a great way of teaching this sort of logic. There we go. Hopefully you've had a moment there to play around with your different options. You'll notice that it doesn't let me use 2 on button A pressed loops because I can't have 2 different instructions for A. But if I choose B, then the block shows itself again. And I just want to show off a sec this show LEDs block, because while the icons themselves are really useful and give you a lot of pre-generated options for different faces and symbols, you can also make your own. So maybe you've got an incredibly happy face. Oh, I'm not good at art. Is that a happy face? I do not know. Oh, I give up. I was trying to make that little emoji with all the teeth. But I think I failed drastically there. But you get the idea. So this is a really nice little project that can be made all the way down to progression step 2 can make this project. All the slides will be uploaded for you to make use of on Hwb, which takes you through this little project we've done step by step and using the different options. So instead of shaking, just tilting to one side or the other. But I won't spend too much longer on that one. I think everyone's probably capable of dragging in those loops and putting a symbol in the middle. So the next project I want to show, still in the health and well-being AOLE, is a step counter. So we've done well-being, maybe more of a focus on health now. So we can use our microbits to make a step counter or a pedometer. And we are going to need our microbit to be able to react to movement instead of pressing a button if we are to make a pedometer. So does anyone feel comfortable answering about what we could use to measure the movement of a microbit as opposed to using a button? No one to answer? No problem. So what we could do, we could reuse that on shake input that we just used. That will work to a certain extent. However, it is unreliable because it is assuming that you're actually physically shaking the microbit about. So if you are running, then it will probably work quite well as it shakes with each step. However, if you gently walk, the on-shake input will not necessarily pick up your movement. By the same account, you could be standing on a shaky floor. You could be on a train or something, and you wouldn't want the microbit picking up your steps if that were the case. Obviously, you're unlikely to take your learners in school onto a train, but that is the sort of point and thought process you can go through with them as to what you should be using to measure this. So what we can do is we can use an acceleration strength measurement. Now the microbit has all these sensors, and these sensors are fairly accurate in what they do. So instead of just basic measurement of whether the microbit is being shaken, it can actually measure the precise acceleration that it is put under. And using this, we can make our step counter. So if I get rid of these blocks, well, our input, we are again going to find under input. If we scroll down, here are these blocks here. So we've got acceleration in mg. And by clicking on the drop-down arrow, we can change that to strength. So x, y, and z being the acceleration in different directions, whereas strength is just the overall strength of that acceleration. And if you remember from the slides, what we were using for this is our logic blocks. Now, logic blocks will be very useful to you when making things in microbit. If statements, which I'm sure many of you have come across before using Scratch, you're checking if a condition is true. So we can check if something is true, then it will do something. And what we are going to check is the strength of our acceleration. So we can check if our acceleration is equal to some value. Okay, once again, I got that equals from within my logic section where I have my comparisons. And just like in Scratch, hexagons drag into hexagons, ovals drag into ovals. And arguably, I think MakeCode Microbit actually makes this a lot clearer than Scratch does by showing these lines connecting between the points. Makes it a lot easier to understand what you're placing where. And the acceleration we were looking for was 1500 mg. Now, obviously, values like this are not something that you necessarily are going to go through with your learners, where they come from. It all depends on the age of the class and their ability. But this is a value that you could just present to them of being the acceleration of a foot. Or you could make a science experiment where before making your pedometer, you have the microbit read out the measurements of people stepping and walking. Make it a larger project instead of just doing a quick pedometer. But anyway, we need this if statement within a forever loop, because otherwise, if we were to put it inside our onStart loop, it would only check once whether the value was true. But now it will repeatedly check this if statement to see if the acceleration is equal to 1500. Okay, so that's the first step of our pedometer completed. We can move on to the next step, which is making ourselves a variable. So we are making a pedometer. We don't just want to know when someone has stepped, but we want to count the number of steps that they do. And so to do this, we are going to need a variable. Skipping ahead there. Now, variables can be found predictably under the Variables tab. And we just need to click the Make a Variable button and call it steps. And click OK. And that gives you some initial blocks for steps. And we are initially going to have to set our steps. Very important, whenever you make a variable, that variable needs to be initialized. And these are just important phrases and techniques to teach the learners. Shouldn't just start counting a variable. You should begin by setting that variable to 0 so that the computer knows to start it on 0. And just for my sake of mind, I'm going to put the on start above forever, but that's just a stylistic choice. So on start, when we begin our program, we want the number of steps we've made to be 0. And we're going to want to show this on the screen. So under basic, we can drag in show number. We're not going to show the number 0. We want to show the variable steps. So under variables, we can drag in our variable that we've made, steps, and place that inside our show number. Go now, if we play this, our microbit just shows the letter 0. Okay, nothing else. But we are going to need this same piece of code inside our forever loop, so that each time a step is made, in other words, each time our acceleration equals about 1500 mg, the force of a step, then we want, under variables, to change the number of steps we've made by 1. Once again, show the number of steps. Okay, now I'm a strong believer in showing learners shortcuts while using computers. Yes, they should absolutely learn to do things the right way. Okay, it's important to go through that repetitive nature, but once they leave school and end up doing things by themselves, they are going to be using these shortcuts every day, and it is surprising the amount of people who do not know basic computer shortcuts, which would make lives a lot easier. So right-clicking on show number, we can use duplicate, and that will duplicate whatever block that we right-click. If you didn't catch that, and then we can place it straight inside our if, instead of having to reassemble those blocks. Now if we run our code, and this might not work on the simulator, to be honest. No, we're not going to get that one to work because, well, I would have to shake my mouse at exactly 1500, which I don't know how to translate that into mouse movement. So that's an important point to see there, that there are limitations to this simulator. It can't necessarily do every single piece of code you may make, but for the majority, it can do them. Okay, if we were to replace this with this entire statement here, acceleration equals 1500, if we were to just replace that with on shake, which actually I can demonstrate here. I just put its shake gesture. Then now my pedometer does actually count. But obviously, as we know, this is not an accurate way to measure steps. So we don't want that. We want this. Okay. So this should be our finalized code. Oh, there's one more step to use the buttons to show you whatever number of steps you're on, or to reset the number of steps. But I won't go through that right now. You've already seen how the buttons work. I'm sure you could put that piece of code together. So once the learners have made a pedometer like this, I'd highly advise you, especially with the microbits, they are quite sturdy pieces of kit. They don't break easily. Believe me, I'm very bad at trying to shake them in a classroom and then letting it fly out of my hand. They are sturdy little devices. So I would, or at least we, when we do this particular workshop, we take elastic bands with us and we tie them to the shoes of the class, and we let them have a quick run around and see how well their pedometers work. Does it accurately count the number of steps that they're making? And if it does, fantastic. But it certainly won't for every member of your class, because not every member of your class is going to have the same force in their steps. So then projects like this provide opportunities for further discussion and to think computationally about what is happening inside the code. Why does it maybe not count accurately for every member? Well, the most likely reason is that the force of their step is different. And you can think through that as a class, work out the logic, let the learners themselves come to the conclusions of maybe why this code doesn't work the same for everyone. There's only one piece in the code that should make it different. And then they can try adapting their code, changing the force of their step, and see if that makes it work. You could even use more than or less than, and use multiple more than or less than, give a range of accelerations that are acceptable. And does that work better? So there is a lot of scope with what you can do with these microbits. Okay, one quick extra project I'll just go through just to round out this health and well-being session is an activity we call positivity. And our positivity, we create a positivity generator. So a magic 8-ball that when you shake it gives you some nice quote, okay, to make you feel better if you're feeling down. So really focusing in on yeah, that idea of well-being and how you know, feeling good, etc. So to make a positivity generator, we first have the learners to drag in an on-shake block, and then create a variable, and that variable we call quote. Oh, sorry, losing my trail of thought here. And when they create a variable called quote, what they're going to do is have it under math pick a random number from 1 to 5. We start at 1 to 5 just because it's easier for learners to fill out 5 quotes. You'll have some that fly ahead and can add more. You'll have others that struggle to write that many. And there we go. Let me quickly make this. So on shake, I'm going to go to variables and make a variable called quote. And I'm going to set quote to be 0 initially, but then from my math section, I can drag in pick random 0 to 10 and save some time. I'm just going to do it between 1 and 3. And then forever. We're going to still need our forever loop for this piece of code, because what we're going to do is we are going to say forever, not if else, just the if true then. And I am going to want to check if my value of quote is equal to 1, 2, or 3. So I can, you know what we should have here actually? Forgetting my own rules, we should be using an on start to start off and set our quote to 0. 1, because initializing variables is important, And 2, because that will make sure that when we put the program on the microbit, it doesn't come up, our quotes don't come up straight away, because they have to be 1 to 3. And if it's 0 at the start, it won't match. Okay, so we're going to check if our variable is equal to the number 1. So under logic, we can find our comparisons, drag in the equals. Under variables, we can drag in our quote variable and pop it in and set it as equal to 1. And if it is equal to 1, then we want to show a string. There we go. So if our quote is equal to 1, I want my positivity generator to say, "You're super smart." Go, a nice positive thing to say to someone. And then we are going to want to click the plus button twice. Okay, when we click plus, it's initially going to give us an else. But for this particular program, we don't want just an empty else statement, because we want to check if it's 1, 2, or 3. So I'm going to get rid of my else, and I just want the one that says else if. Else if my quote is equal to 2, so drag in an equals, drag in a quote from variable, and equal to 2. And if it is, then I want to show another string that says "You're a wonderful person." I am struggling to think of positive things to say at 20 to 5 on this Tuesday evening. Okay, so we do the same thing again, get rid of our else, and again, just going to right click, duplicate, make life a little bit easier for ourselves. If our quote is equal to 3, then I want my positivity generator to say, "You are important." And there we go. So a project like that, once again, I think all 3 projects that we've covered this afternoon aren't particularly complicated things to program. Depending on the level of your learners, it will depend how long it takes them to do that. But I'd say most progression steps 2 and 3, should be able to do this in class. The concepts included are not particularly complicated. Maybe the random number generating takes a bit more thought, or especially in the step counter, the acceleration, the understanding of what acceleration is a conversation to have. But the computational logic that we've covered is fairly simple, and I'd be comfortable presenting these workshops all the way down to year 3 and 4. So there we go. That shows you just how simple it can be making these things in MakeCode microbit, and hopefully you all feel a bit more comfortable doing that now. And this has given you a nice introduction to the things you can do in MakeCode microbit. I will say this particular piece of code here is what I presented in the launch session for Microbit the Next Gen with the BBC. That was in Cardiff back in September. So this is the the piece of code that the BBC wanted to use in their session to roll out the microbits. The only difference is when we did it for the BBC, it was a exercise suggestion. So exactly the same exactly the same code, but instead of giving a positive quote to someone, it suggested a type of exercise. So do 10 laps, do 5 push-ups, do 20 star jumps. So hopefully that gives you some thought there as well about how you can use the exact same code, but apply it to entirely different situations depending on what you need out of a lesson at that time. Okay then, just to finish off, as I said, we are focused at TechWordCamps about using microbits across the curriculum and supporting the new digital literacy framework, and taking digital literacy out of the IT room and into lessons, into learning about other subjects, just as you do with literacy and numeracy. And there's no reason that cannot be done, especially when you've got something as simple and powerful as a microbit at your fingertips. So I just want to show you a couple of examples that we have in our workshops of using the microbit across different AOLEs. So some examples that we use in science and technology. As I mentioned at the start, you can use the pins on the microbit to detect an electrical current. So a simple bit of code here, checking if pin 0 on the microbit has been pressed. And if it does, it shows one icon and plays a tone. If pin 0 hasn't been pressed, or if there is no electrical current running through it, then all sounds stop and it turns to a happy face to show you that it's nice and safe. You can use this piece of code to run electricities through fruits. We've taken bananas into workshop in the past to check whether they conduct electricity, and the microbit will make a nice sound when it's plugged into a banana. It won't do that if you plug it into a cushion, for instance. Or again, a bit more complicated, you can plot a bar graph on the microbit's 25 LEDs of the light level in the room. For humanities, we have a workshop where all about biodiversity. So we use our microbit to create a species counter. Now, when we do this, we are doing it within the classroom, but a lot of you at primary schools have lovely lakes and fields where you can go out with the microbits and do this sort of project for real and measure what different species that you come across on your time outside. Different pupils could be searching for different amounts for different types of species and counting them up. You could split them into groups. There's an awful lot you could do just with a simple counter. Or for a slightly older class, when you're learning about angles, you can turn your microbit into a compass. It has an internal compass. So just by measuring the tilt, the direction the microbit is facing from the number of degrees off north it is, you can turn it into a working compass and show you which direction you are facing. As I mentioned, there is a radio transmitter inside the microbit. So for languages, literacy and communication, you can do a lot with secret codes. We use it at TechnoCamps for Morse code and sending Morse code messages between microbits. But you could come up with all sorts of secret codes or even translate in between English and Welsh, say, and using the radio transmitter to check translations being sent across. In mathematics and numeracy, we can just use our random number generator to turn our microbit into a dice. Okay, save all your learners having to throw dice around the class, which we do that in our workshops as well. That's I know how fun that can be when you've got 30 dice being thrown around. So at least that makes that a little bit easier. Or getting a bit more complicated as well, you can use it as a times table checker for kids to get two random numbers by pressing A and B, and then have to work out the multiplication of those numbers, and the microbit will tell them if they got it right. And then for the expressive arts, as I said, the microbit has a lot of musical capability. You can even program chords into it and get the microbit to play some broken chords. You can step that all the way up to teaching all about octaves and whatever you desire. So there's a lot you can do with a microbit, turning it into a piano and all sorts of things if you really want to get into it. But it can be lovely just to make some simple animations, a nice introduction to animation for your learners, where they've only got 25 LEDs to worry about creating their animation. This is one I made of Tetris, and I'm very proud of it. It took quite a while to work out how to actually make it loop. You don't realize how hard it is until you start to do it. There we go. Anyway, I just want to finish off by letting you all know that at Technocamps, obviously, we are still here to support you and develop your learner skills. And especially now with the microbits and being partnered with the Microbit Foundation, we have created 9 new workshops focused on the microbit and using them in your classrooms. So these are the workshops we have available. If you have any interest in doing them, then please do contact us. If you don't know our details, they are on the Technocamps website, but we'd be more than happy to come into your schools and deliver these resources for you. If you don't have time for that, or you would like to just use our resources on your own, then a lot of these are available on the Technocamps website, and you can use this link to go directly to that page and find all of our microbit resources that we have uploaded for you for free to use in your own time. That is the end of my workshop. So thank you all very much. I'm sorry I have gone 3 minutes over there, but I hope you have all enjoyed and found this useful and beneficial for the microbits that you now all have access to, I hope. And good luck for the future.
Diolch yn fawr, Dan. Thank you very much. That was really great. Gobeithio eich bod wedi mwynhau'r sesiwn Hwb yn gyflwyno Microbits with Technocamps. Cadwch lygaid am ragor o digwyddiadau Hwb yn gyflwyno yn fuan. We hope you enjoyed this Hwb Presents Microbits with Technocamps session. Look out for more Hwb Presents sessions soon. More information about those can be found on Hwb and our social media channels. Please share those with your colleagues. Bydd y recordiad a sleidiau ar gael ar Hwb yn fuan hefyd. The recording of this session and the slides will be available shortly on Hwb. Last thing just to mention to you all is there are some really exciting ways to get more involved with using microbits in the coming academic year with the Microbit Foundation's Playground Survey, which is going to be launched in February, so keep your eyes open for that. Diolch I Dan eto, a diolch I chi gyd. Hwyl fawr, diolch eto.